new thread, it will be running in your old thread only, main thread. What is thread priority? Before starting any of the task, what we can do, we can set the priority of a thread. So how to set a priority? Set priority is the method name. Okay, so typically there are different ways to set the priority. Okay, so minimum is 1, maximum is 5 or 10 depending upon your operating system. Okay, so and what is the normal? What is normal? Normal is in between. Okay, so minimum, high and normal. So these are the 3 states, but you can set it as per your requirement. Okay, this you think. Then what is daemon thread? Daemon threads are nothing but service provider. Okay, so they are helping thread to your main user thread, basically main thread or worker thread. And what are the examples of daemon threads? Something like garbage collection, finalizer. And whenever your user thread will die, what will happen? Daemon thread will automatically die. Okay, why? Because those are of no use, right? If your user thread is not working. Okay, how to set a thread daemon? Set daemon true. Okay, and can you set your already started thread as daemon? No. Okay, before starting only you have to set the thread as daemon. Then we have seen what is shutdown loop. If your application is abruptly terminated, then before abruptly terminated you want to do some sort of task. So where you will do, you should put it in your add shutdown hook. Okay, so how to write the code? This is the one, runtime dot add shutdown hook will do. And garbage collection, what is garbage collection? If you have some sort of data, okay, unwanted resources available in your memory, okay, so which are unnecessarily taking space in your wherever it is. Okay, so in Java, how to collect garbage? AGC, automatic garbage collection. Okay, so we can do it, system.gc, but it is not advisable. Even if you do it, it is of no use. If JVM is busy in doing some expensive task, he will ignore your request. Okay, so we can just request to JVM that please consider my request. Okay, but it is up to him. Whether he can do or not, it is up to him. Yeah. Now, then we have seen what is runtime. Runtime is one of those class by which you can execute some task. Okay, so what is the method to execute? Exec, and you just pass the command name, it will automatically execute the command, which I think we have done till this only. We'll start from here. So synchronization. What is synchronization? Any idea? What is synchronization? Any idea? Tell me. What is synchronization? So synchronization is something like only one thread will work at a time. Okay, multiple thread will not work. Only one thread will work at a time. Okay. So suppose I think we had already looked into this example. Okay, so suppose ATM machine example. Okay, so suppose let's go to this ATM machine, HDFC ATM machine. There are 2 ATM machines which are available. Okay, so but account is same. It can have, right? Because you can have 2 ATM card joint holder. Okay, so for joint holder we can have 2 ATM cards. So suppose my ATM card number something like this. Okay, and other ATM card is like this. Okay, and this is my ATM card. Okay, and my brother ATM card, and we are joint holder of one of the account. Okay, so account number is maybe any number. Okay, so this is the number of the account. Okay, so now as we are doing multi-threading, what will happen? More than one thread will work together. Okay, so suppose in your code we are having one of the method called withdraw, like this. Withdraw is the method like this, which is withdraw, and here we pass how much money you are withdrawing, money, how much money you are withdrawing. It will be like this. Okay, and then how the logic will be? It will be very simple. Total money equal to, if total money is the total money which is available in your account, then total money equal to total money minus money. So the amount which you are withdrawing, so it will look like this. Okay, so try to understand. Suppose if you go to ATM, my brother um, let's think in my account now 10,000 rupees is there. Okay, so what will do, my brother will insert the card, I will also insert the card. Okay, and now how many threads will be started? 2 thread, one thread by me, one thread by my brother. Okay, so now suddenly what will happen here, whenever we will come here, this particular line number 15 can be executed by 2 thread, right, simultaneously, because we are working with multi-threaded environment. Even if millisecond is same, what will happen? It will come and it will execute the same line. Then what will happen? Both of us will get money, right? So if 10,000 rupees is in my account, he will also get 10,000, I will also get 10,000. Then 20,000 will get. We are getting my point, what I am to say? This is possible, right? If we are doing multi-thread, as we know, multi-threading means more than one thread can work at a time. Then if this particular line will be executed by 2 threads, simultaneously can happen, right? That's what is the multi-threading. So now it will happen, what will happen? Both of us will get money. Theoretically it is possible, practically also it is possible. I mean, if your millisecond all the time is also same, then it is possible. Then now it is only 10,000. Okay, so maybe crores of rupees transaction happens, right, in your banking system. So it will create a lot of problems. Are you able to understand? So in this case, you want to elaborate the facility of your multi-threading, but you don't want to execute both the threads together. Only for certain cases, something like withdrawal of money. Got it, right? So withdrawal of money is some sensitive case where 2 threads should not work together. Only one thread should work, whether me or my brother. As soon as I am done, then okay, let my brother come. That time when he'll check, his balance is not there. Something like this will come into picture. Got it, right? So in this case, what we should do, we should never write the code in multi-thread environment. Now, this synchronization concept will come into picture. Got it, right? So what is synchronization? Synchronization is nothing but the mechanism by which only one thread will work at a time. What is synchronization? Synchronization is nothing but the mechanism by which what will happen? Only one thread will work at a time. Okay, only one thread can work at a time. So synchronization is a mechanism by which what will happen? Only one thread will work at a time. No more than one thread will work. Okay. So now there are different ways to achieve synchronization. Okay. So typically we say it in 2 ways. One is called mutual exclusive, and another is called cooperation, or we call this the inter-thread communication. Okay. Now mutual exclusive can be divided into 2 parts. One is called synchronized method. Another is called synchronized block. One is synchronized method, another is called synchronized block. Okay, and inter-thread communication. We use this wait and notify. We use one of the mechanism called wait and notify to achieve this synchronization. So there are two ways to achieve mutual exclusive and cooperation. Mutual exclusive can be divided into two parts. One is called synchronized method, synchronized block, and cooperation is nothing but wait and notify mechanism. Okay, wait and notify mechanism which we use over there. Okay, so let's try to do one thing. Okay, so let's so that's what. So what is synchronization? The capability to control the access to any shared resources. Okay, and we can do in two ways: mutual exclusive and cooperation. Which one mode is there? Okay, so here we have static synchronization. Static. What is the one? Static synchronization. This one, no, static synchronization is one of the way. This is the third way. Okay, so now let's discuss about the concept called lock. What is a lock? What is lock in normal term? I mean, in general term, what does lock means? Lock means if you lock with that, then what will happen? Nobody can use it. If I lock my room, what will happen? Nobody can come to my room. Okay. Similarly, here also in your Java, if you are having some resource, if you are having some object or any data, if you put lock, then what will happen? Nobody can use it. Now, suppose I stay in my home. Okay. So I lock it. Then anybody can go inside? No. When they can go inside? When I open the lock. When I remove the lock. Are you able to understand? So similarly, here also in Java, if you don't want that particular resource to be accessed by anybody, then what you do? Just put the lock. Okay. Now, as soon as you want that particular thing to be accessed by anybody, then what you do? You release the lock. So put the lock and releasing the lock. Okay. So this is the mechanism which we use. Okay. So what does lock means? Now tell me, lock is part of thread or it is part of your resource? Thread or resource? So now tell me, lock is part of my room or lock is part of me? It is part of your room. Room means it is resource. Okay. So it is very misconception which you are having. We think that lock is part of thread, but lock is not part of thread. Yeah, thread will also have lock. Why? Because thread is also one type of resource, right? Thread is also one of the object, right? So thread can also have lock, but all the other objects can also have lock. Okay. So what is lock? Lock is nothing but, okay, so the way, okay, so there are two ways. Okay, so one is acquiring the lock. Okay, what is the other one? Releasing the lock. What does acquiring the lock means? Acquiring the lock means if the lock is acquired on any of the object, okay, then no other thread can work on it until unless someone will not release the lock. Okay. And what is releasing the lock? Releasing the lock means giving access of resource to others. Okay, so giving access of resource to others is nothing but releasing the lock. That means other people can also use it now, no? The resource which you are using. Okay, so acquiring the lock, and what is the another one? Releasing the lock. When somebody release the lock, what will happen? Anybody can be access that particular data. Okay, now tell me, lock is which property? It is object property. It is not thread property. Okay, so lock is always an object property. It's not only the thread property. Okay, so if somebody asks what from where lock is coming, lock will come from object. Okay, lock is resource property, right? So thread can also have lock. Why? Because thread is also a resource. Thread is also an object basically. Okay, so all object can have lock. Okay, inbuilt. Those are, so lock is, it is inbuilt. It is inbuilt property. Okay, so lock is an inbuilt property of an object, any object. Okay, so let's try to look into one of those examples by which we will be able to understand. So, what is a lock? Every object has a lock associated with it. Okay, a thread that needs consistent access to an object field has to acquire the object's lock before accessing them, then release the lock when it is done with the task basically. Done with them. Now we'll look into these two things. Okay, method level and block level lock. Okay, so now before going ahead, okay, let's try to understand one very simple thing. So we'll do one example by which we'll be able to understand. Okay, so there I will create two threads. Okay, and one thread is your 5. You know table. What is table? At your table means in your school days, so we call Namta or Pahada. We call Pahada, very famous Pahada. Okay, so in school every day, I mean, before finishing the class, 4 o'clock, 4 o'clock class, right, 10 to 4. So before 4, maybe 3:45, what will happen? One guy will come ahead and they will do ekam do duni char. Okay, so all those things. Okay, so let's try to remind our school days. Okay, so we want to write the code so that it will generate the table for us. Okay, so if I'll pass a number called 5, then it should give me the table of 5. If I'll pass a number called 11, then what will happen? It should give me the table of 11. Okay, so now what we'll do, if you want to write this code, how will you write the code? So typically how will your method will look like? Public, then void. Okay, so table, some sort of, I am giving the name called table creation, and we'll pass the number for which you want to create the table. Okay, so I'll pass the number. So what is table? Table is nothing but do ekam do duni char do diya che. So what is happening? Increment is happening and looping is also there, right? So for looping, what we have to use for loop or while loop, anyone using. Okay, so let's try to use for loop. Int I equal to 1. I'll start from 1. Okay, then how will you do? I is less than 11. Okay, I want to include 10 also. So what happened? I have done less than 11, means 10 will come. 1 to 10. Okay, then what to do? I plus plus. Okay, and if you want to print something, how will you print? System.out.println, SOP, system.out.println, and I want to print that number. So how I'll print? Tell me. Number into I. Okay, so if the number is 5, then what will happen? 5 1 5 5 2 10 5 3 15. So it will keep on printing like this. So this is the base core logic of our table. Very simple logic. Very simple logic which we are looking into. Okay, so now try to think, if I'm having one of the class. Okay, so suppose my class name is okay, table. What is the class name? table is my class name, and inside table what I am doing, I am writing like this. Okay, inside table what I am doing, I am writing in this particular class. Now whenever I will print the table, what is table? Table is a resource, right? When you create the object, it will become resource. Now if I am having two threads, suppose one thread is printing the table for 7, another thread is printing the table for 5, then both threads can work together. So 7 and 5 will mix together, right? Similar to this, suppose in this room, okay, one people is telling the pada of 7. If I go to another room, somebody is telling the pada of 5, then 5 7 will mix, right? Got it, right? So that is against the synchronization. That means that is your multi-threaded environment where you are doing the task concurrently. Now what you want to do is first 5 complete, then 7 complete. So if you are able to achieve that particular thing, then what is happening? You are able to achieve synchronization also. Very simple. Okay. So let's try to do a very simple example which will help us out to understand. First we'll jumble all those things, then we'll try to segregate 7 first, then 5 second. Okay. So we will try to do that. Okay. So for this we'll create one of the class. Okay. So I class something like I'll give my thread. Suppose I want to have the pada of 5, then 5 extend thread. So this is the thread which is responsible to print the table of 5. Okay, so automatically it will have what method? Run method will come. Run method will be there. Okay, and we'll create one constructor also. Okay, we'll create one constructor here. Okay, and in constructor what we pass the table for which you want to create the table. So whenever you will create thread, you have to pass the table for which you want to create the table. So I'll pass the resource basically. Okay, yeah. Now we'll do shadow. So how to do shadow? What is shadowing? Shadowing nothing but same name is your instance variable and local variable. Okay. So how to remove the shadow? We use this. If you remember, we have already done during shadowing. Okay, this is table. So we'll write the code like this. So I got the resource on table object, and run. What run method will do? Run method will very simple. It will just print the table. Table dot. What is the one? Table creation is my method name. Table creation. Okay, and it will pass the table for 5. Okay. Similarly, we'll have one more thread. What is the other thread called? Other thread will be your 7. Because from here you want to pass 7, right? So we'll make it 7 7 8 7. So there are two threads. One is your 5 thread, another is called 7 thread. 5 thread is printing the table of 5, 7 thread is printing the table of 7. Now if we'll write the code in this way, okay. Now what we do? We go here, table equal to new table. This is the way how we create. So this will run from your main method. Okay. Now what we do? We will write something like my thread 5 equal to thread 5 equal to new my thread 5, and what we have to pass? We have to pass the object of table. Why? Because in constructor we are passing here, right? Constructor we are passing now, so we have to pass it. Okay. Similarly, what we do? We will do for 7 like this. Here also 7. And how to start a thread? How to start a dot start. Control D. Here also 7. Now tell me what will happen. Because it is a thread, so what will happen? It will be jumbled. 5 sometimes, 7 sometimes, 5 sometimes, 7 sometimes. Okay. So this is the normal implementation which are having. Okay, all to jumbled over there. Okay. So let's try to do the same thing in our code. Okay. So just close it. We want to print the table. So first we want to create the table. So table class. Table is my class name. Okay, and it is having one of the method which we discussed here. What is the method name? Table creation is my method name. Okay, and we will make it public because we want to call it from outside also. So we will make it public, and we will pass a number for which we want to create the table. Okay, we want to print the table. So how we do? For loop. We write for loop, and how to start? It will start from 1. It will go till 11. Okay, so because less than 11 means till 10. Okay, and and we want to print the table. So SYSO, we want to print the table. So this is for your plus. First we'll give the number, okay, then we'll give this into hello ठीक है আমি কল করছি একটু পরে okay, then what we have to pass, we have to pass the number is there. I just want to show the I also, okay, I, and I want to show that, okay, so I will give one space so that I can understand, okay, plus what is the output we want to show, number into I. So very simple. This one you cannot, you can use, you cannot use, it is up to you. This part I am writing so that you can understand this is 5 table or 7 table, like otherwise you will not be able to understand, right? So maybe some number will be mixed, right, in both the places, okay. So we are having number into I means 5 into 1 equal to 5, 5 into 2 equal to 10, 5 into 3 equal to 15. So it will come in your photo, okay. So that's why we are writing like this, okay. So this is your table creation. Now what to do, we want to create 2 threads, okay, 5 thread and 7 thread. So we'll go and create the thread. We will go here and create the class my thread 5. It extends. Suppose I am going for thread implement, so I will use thread, okay, thread, and automatically what method will come, run method will be coming here. Run method will come, right, and what you want to do, you want to have one constructor of your thread. So how will you create constructor will have same name as your class name, okay, and you want to pass the table object here. So table. So this is shadowing. If you want to remove the shadow, how to do, table equal to table, and table equal to this, this dot table equal to table. It is not mandatory to go with the shadowing, okay. If you don't want to go to shadow, then what to do, you have to give some different variable, table 1 and also table 1, then no need to have this, okay. But it is best practice, you should have the same name, and what run method is doing, run method is printing the table. So table dot, what is the one, we are having a method called table creation. I will pass the number called 5, that's all. So this thread is creating the table for 5. Similarly, one more thread will have, what is the another thread, 7 table, okay. So we will give this one called my thread 7, my thread 7, and what this my thread 7 is doing, it should print the table for 7, and just change, other things will remain same, okay. Yeah, now if I'll go to, now I'll go to my entry point. What is the entry point, main class, from where we are printing. So we'll just comment all the things which we are doing, okay, and we'll write fresh from here, okay. Now we'll create the table equal to new table, okay. And what is the resource here, table is the resource, because you want to print the table, so table is your resource, okay. And what I'll do, my thread 5 equal to new my thread 5, and what is the resource, I have to pass table, okay. Similar to this, you want to print the table for 7 also. So what I'll do here, I'll make it to 7 and 7, correct, okay. Yeah, so now tell me, what is the resource for them, both the threads are fighting, table is the resource. So this is also called race condition. What is this called, race condition? I think you might have studied in your college, right? So what is race condition? So what is race condition? I mean, both the threads are fighting for this resource, okay, that is called race condition, okay. So note it down, so race condition. What is race condition? Race condition is nothing but, okay, the condition where multiple threads are fighting for the common resource. So the condition where multiple threads are fighting for the common resource, that is called rest condition. Okay. So the condition where multiple threads are fighting for the common resource. And what is the common resource in our example? Table is your common example. Okay, so table is your common resource. In this example, table is the one which is creating rest condition. Resource is your table. Okay, so yeah, now we want to start this. So how to do my thread 5 dot start. Similarly, what to do my thread 7 dot start. Okay, let's run this code. What is happening? So are you able to see what the problem is here? See, 5 7 5 7 all are jumbled. Sometimes 5, sometimes 10, sometimes 7, sometimes something is coming. Are you able to understand? So this is the problem which I told little bit earlier. I am withdrawing, my brother is withdrawing. I am withdrawing, my brother is withdrawing. So all are happening together. I mean, those are jumbled basically. Okay. Now you don't want to jumble. Okay. So what you want to do? First 5 complete, then 7. So what is it? This is called synchronization. That is the thing which you want to achieve. Okay. So very simple. How will you achieve this? Go to your table object. This is the where rest condition is there, right? So just make this method as synchronize. That's all. That's all. Only one small change. What is the one? Synchronize. Make your method synchronize. That's all. Now what will happen? Any of the thread will come. What will happen? It will stop over there. Okay. And it will start working on it. So synchronize you can do, but we have to make your thread sleep for some time. Why? Because maybe before executing, what will happen? Before executing second thread, what will happen? First thread also started, right? So what should have? We should have some sort of wait for this. Okay. So how to hold a thread for some amount of time? Thread dot sleep is the method name. What is the one? Thread dot sleep. Okay. And suppose I want to hold it for maybe 500 seconds. Okay. So I will just make it sleep. So you understood why I am making it slip. Why? Because maybe first before synchronization both the threads started and 5 7 started and they finished their work. Got it, right? So that's why we must have sleep, so that I am giving some time for the second thread to come to know that this thread is blocked. I mean, this thread is blocked by somebody else basically. Okay. So that's all. So we have to have sleep. Now let's try to run this code. What should happen? See what is happening. See, 5. All 5 are finishing first. See, all 5 are finishing, but then 7 is starting. Got it, right? So why it happened is, whenever you started the 5 table, automatically it locked that particular resource table. Now when he is finished, then he released the lock. Now 7 started printing the things. Got it, right? So this is the way how you can achieve synchronization basically. Okay. So as we are writing this in your method, what is this called? This is called method synchronization. This is called method level synchronization. Okay. So see here what is happening. 7. If 7 is started, see 7. Earlier 5 was started. Now 7 is started. So 7 is started earlier than 5. Why? Because this is threading. You don't know which will start first. But as soon as any thread started, it will complete the task. Then only other thread will start working on that. So now this 5 is starting. You don't know the order. I mean, which thread will start first? They will acquire the lock. When he is finished, then other thread will come into picture. Got it, right? So this is nothing but your synchronization. So this is nothing but your method synchronization. So first one is your method synchronization. Okay, what is method synchronization? Very simple. This is the syntax. You just use the synchronized keyword. Synchronized keyword. That's all. Just put the synchronize. Just top of your variable. This is method. It will be called your method synchronization. Okay. Another way to put the lock. How to put the lock? You just release it. Okay. And you use this synchronized block. Okay. And you just put you just put table dot class. This is another way to put the lock. Okay, this is another way to put the lock. Okay, what is this called? This is called synchronize block. See, I am putting the block. I am not writing in the method, I am writing in the block. This is called block level synchronization. Okay, both are same. Internally both are same. Okay, so only difference here is only the way how we are writing the code. So there are two ways to achieve the synchronization. First one is method synchronization, and another is called synchronize block. So this is the way how we put the block. Okay, if you run this code again, same thing. 5 is started, so 5 will finish, then your 7 will come into picture. Then 7 started, 7 will finish. Okay, both are same. Now, which is good, block level or method level? Block level. Why? Why block level?
Particular block you can use the if you don't want to about
you are right, you are absolutely right. Okay, so try to understand it. Again, it depends upon the requirement, how you want to implement. Okay, so if you want to have full this method is synchronization, then better to go for synchronize method. But if what you want to do, if you want to synchronize only this line and below line, if you are having some line called system.out.println, here I am printing tapas. Then if I will make my method synchronization, what will happen? Everything will become synchronized. Means even this particular printing will also become synchronized. Are you able to understand? But if I use synchronized block, what will happen? Only this line will be synchronized. This tapas is not synchronized. Okay. So depending upon your requirement, if you want to make full method is synchronized, then what is the one best way to make your method synchronized? If you don't want to make your full method synchronized, you want to make the part of it is synchronized, other things are not synchronized, then which one go for? You should go for your block level synchronization. Okay, so now method or block level synchronization are used based on the requirement. Okay, if the whole method is synchronized, better to go for method. Okay, method level. If part of it is synchronized, but it's better to go for block level. Okay, it's better to go for block level. So it's up to the requirement. Okay, how you want to implement it. So if the whole method is synchronized, better to go for method level. If your part of a method is synchronized, then better to go for block level. Okay. Okay. So yeah, we will wrap it up here. So that's what. So synchronization can be achieved two things: method level and block level. Okay, and we'll continue from here. Okay, next from static synchronization.